because of induction, a charged body attracts an uncharged body. If this is a glass rod which is positively charged and here is an uncharged body, the electrons will try to come closer to the glass rod. So this side will get minus charged and this side will get plus charge because the plus charge will stay behind. Now in conductors the electrons will actually move. In non-conductors the electrons will try to spend more time this side because here is a positive charge. So therefore this induction will take place in conductors as well as non-conductors. Now there will be an attractive force between this plus charge and this minus charge, and there will be a repulsive force between this plus charge and that plus charge. The minus charge is same as the plus charge because electrons have come here, so charge, plus charge and minus charge are equal in magnitude. These two are closer, so the attractive force is more. These two are far away. The plus charges are far away from each other, so the repulsive force is less. Since the attractive force is more, this body will get attracted to this. So because of induction, a charged body can attract an uncharged body, both conductors as well as non-conductors. We have learnt about frictional electricity and that we experience in so many places in our day-to-day lives. When you comb our hair in dry weather, after some time the comb can attract bits of paper. When we try to remove plastic covering from chocolate boxes or even from these marker pens, that plastic gets charged. If we rub balloon on our clothes, the balloon gets charged. All this happens in dry weather because in wet weather the air conducts away the electricity, so charging does not last for a long time. One question someone may ask you: can two similarly charged bodies attract each other? Suppose this is a positively charged body and here is a body which is plus charged, little bit, not too much, is big in size. So now this positively charged body will try to push away all the plus charge and pull the minus charge this side. So the electrons will come this side and this plus charge will try to move away. Because the plus charge is more, because the body was initially positively charged, it will be slightly more than the minus charge. But if in this situation the attractive force between this plus and this minus is more than the repulsive force between this plus and this plus, the body can still get attracted. Okay, so two similarly charged bodies can attract each other in this kind of situation when one is having a much higher amount of charge compared to the other and the other body is slightly big in size. If they are point charges, then this will never happen. If this is plus charge, this is plus charge. If they are both plus, there will be no induction, so they will never attract each other. If this is minus Q, this is minus Q, then also they will never attract each other. Two similarly charged point charges can never attract each other, but two similarly charged bodies can attract each other in some special situation. One question somebody may ask you: does charging result in change of mass? Now, that is something that you must understand. Okay, this is coming JEE Advanced also. Charging involves movement of electrons. Electrons move from one body to another, and electrons have mass. So therefore, charging results in change of mass. Suppose we want to charge a body to a very high voltage. How can we do that? Okay, that equipment is called Graaff Generator. Suppose we have a hollow spherical conductor, okay, and we want to charge this. to a high voltage. Suppose we have a system to charge a body. Suppose we rub glass and that glass rod gets plus charge. So this rod we are charging to some potential we'll learn a little bit later, some voltage, by rubbing it with silk. So this glass rod is plus charge. Now when this glass rod is brought in contact with this spherical conductor which is on an insulated stand, some charge will flow from here to here till the potential of this becomes equal to the potential of this. Now again we can take this rod, again we can charge it. Okay, so charge will increase, the potential will increase, and again if we touch it, more charge will flow till the potential becomes same. And this process we keep on repeating, charge will keep on flowing. After some time, the charge flow will stop when the potential of this and the potential of this are exactly same. So when this rod is fully charged, whatever potential this has is the same as the potential of this now, therefore charge flow will stop. So we cannot charge this spherical body to higher potential than the potential of the glass rod, because for charge to flow we need a potential difference. So now how can we charge this to higher voltage? This solution was found out by Professor Van de Graaff. He realized if this charge, instead of touching it from outside of this, if you touch it from inside, then charge will always flow from this glass rod to this sphere. Easy way to understand this is that the charges repel each other, like charges repel each other, so they want to be as far away as each other from each other. So therefore all of them, charge will try to go to the outer surface. We'll discuss this mathematically, okay, as we go on in the course. But now let us understand it in simple terms. So when you touch it from inside, all the charge wants to go to the outer surface. So charge will go to the outer surface. Now again we charge it, again we touch it from inside. Then the charge will go to this. And whatever times we do it, always the charge will go to the outer surface. Now we can charge this sphere to a very high potential. Okay, till breakdown occurs. Because when you charge it too much, then at some point of time, the air, which is normally an insulator, will start conducting that. Okay, that is called breakdown. So breakdown potential will reach. So till that point we can charge this using this equipment. So instead of touching it from outside, if you touch it from inside, then you can charge this to a very high potential.